Hi everybody, this is Mr. Nolan, and I just want to take some time today to talk to you about fluxes. What are fluxes? What does flux mean? So for the last several months, we've been discussing carbon, carbon dioxide, carbon-containing organic molecules, things like glucose, fat, protein, and also where carbon is located in the atmosphere, or is it in organisms, or is it underground, or is it in water? Where is it? So really all along, even though we didn't use the word, we've really been talking about carbon fluxes. And so we're going to try to define this and make sure that it's clear to us what do we mean when we say carbon fluxes, and how do we figure them out, because we're also going to want to be able to do some graphing. So in this short video, all I'm going to discuss with you is just what a flux is, right? So what is a flux? So what the flux, right? This is really what we're looking at, is what is a flux. What we should be able to do at the end of these two videos, there's really two. There's this one, and then I'm going to make another one that talks about more the mathematics and the graphing behind it. What our goal should be is to be able to graph and explain the carbon fluxes in certain ecosystems and situations. And that might sound like kind of a vague mandate. Okay, be able to graph and explain. Well, we really want to be able to talk about this is what flux means. We have to define it. We have to make sure that we know what this is. So that's the first thing that we're going to do, is just clarify, make sure we know what it is, and how do they behave. And then in the next video, in this sort of two-part series, we'll go ahead and talk about, how do you actually graph these things? How does this work? So to begin, let's kind of look at our warm-up, just to see what do we mean when we talk about fluxes. So I mentioned at the very beginning of this video that a flux is something that we've really been talking about all year long. And so to start off today, what we did was we modeled something that's kind of familiar to us. How does carbon move between these different carbon pools? We've got an atmosphere, we've got forest, we've got a deer. It's a very simplified sort of carbon cycle situation that we're going to model. So what I would encourage you to do is to take a moment to pause the video and take a piece of paper and just kind of sketch out how would carbon move in this ecosystem. So go ahead and pause and take a moment to do that, or at least think about it, and then I will put that model on the screen. Okay, so what I've done here is I've very simply modeled what our carbon is doing. Our forest is going to be doing two things with carbon. One thing is that it is photosynthesizing. Now, when a plant, such as trees in a forest, when they photosynthesize, they pull the carbon dioxide out of the atmosphere, and that becomes converted into organic carbon in the forest. But at the same time, don't forget that the forest is also respiring. The trees that are in the forest are doing respiration as well. So you're also going to have some carbon coming out of that forest because of cellular respiration. Now, this whole idea doesn't make really any sense unless you understand flux. We'll talk about that. Here, we have our carbon moving from our forest to our deer through the process of eating. And so that's why I've drawn a red arrow from the forest to the deer. The deer is eating some trees or some sort of vegetation in that forest. So our carbon is moving from the forest to the deer, and so that's why we draw an arrow to the deer. And at the same time, our deer is breathing. And that same carbon that the deer ate from the forest floor, the leaves, whatever is in the forest, he's also breathing out. And so that carbon that makes up part of the deer for a while is actually breathed out when he or she does cellular respiration. And then it goes back into the atmosphere. And so we really have three pools here. We have the atmosphere, we have forest, and we have animals. In this case, we have three pools. There's really a lot of different carbon pools. But here's the idea of a flux. The whole idea of a flux is that each arrow that we have drawn here and that we have kind of been getting used to over the course of the last couple of weeks, each of these arrows is a flux. It's a carbon flux. So these all are fluxes, and what that means is that the idea of a flux really should be kind of familiar to you. If you draw an arrow showing that carbon is moving between two different pools, that is a flux. So in short, or as short as we can really get it while being accurate, a flux is the flow. Really, that's where the word flux comes from, is the Latin for flow. It is the flow or rate of movement of a substance from one pool to another pool. And so really this is the idea behind flux. It's really a flow, right? It's really a flow of something from one pool to another, and the substance that we are talking about is carbon. In this case, this is what we're talking about. So this is the idea behind a flux. It's simply a flow or rate of movement of a substance from one pool to another pool. And pool is a metaphor. And so we're going to look at this metaphor right now, just so that we, again, just to kind of hammer home, this is exactly what we're talking about when we talk about a pool. Okay, so imagine a pool, okay, a literal pool. You have an actual pool. And we are talking about these things called carbon pools. And so how is this a metaphor for how carbon is moving around? Well, imagine that you have a hose. Our hose has a little nozzle here. And we have a spigot down here. It's got a little handle. And the hose is pouring water into the pool. So we're actually pouring water into this pool. Our hose is actually pouring water into the pool. At the same time, our spigot is letting some water out of the pool. So water is coming out of the pool at the same time. We have water coming in. We have water coming out. Now, here's what I think is the best way to think of fluxes. If we're going to talk about fluxes, flux means flow, literally means flow. And so if we're looking over here at these flows of this water in this pool, I'm going to get rid of this here. What we're really talking about is simply how much water are you adding and how much water are you subtracting. So over here, I would call this part, our hose, your positive flux. It is your flux into the pool, right? This is our carbon pool. So this is our pool. And the spigot represents our negative flux. It represents a loss of whatever substance we're talking about. So we have two kinds of fluxes for each pool. Yes, it's possible to have many locations where carbon is coming from or many locations where it's going, but the main idea is that you have a positive, an input, and then you have a negative or an output, something that is coming out here. So we can start to think in terms of numbers. We can start very simply just by thinking of, gallons, right? We have a pool here, if we could think of gallons. So let's say that we added 1 gallon to our pool. And then we subtracted another gallon. What that means is that our carbon is flowing in at the same rate that it is flowing out. Well, here's how we would start to do a little bit of the math. I'm not going to get into graphing or anything in this video, but I want to start getting into the math behind how to deal with this. You take your fluxes. If you want to figure out what is now the change in my pool, right? How can I mathematically describe how this pool is behaving? If I want to show how the amount of water in the pool changes, all I have to do is add the fluxes. Both of them. So what I would do is I would add my plus 1 gallon, and I would add my negative 1 gallon. Always add them. And what I'm going to end up with at the end is 0 gallons. Now what this does not mean is that my pool has 0 gallons of water in it. What this means is that this is my net flux, or my net change. This is the interesting part, is that when you start adding up your fluxes, you can actually figure out, well, how much did my pool change over the course of this time period? We can take a few other really simple examples. So let me go ahead and clear this off. We can do a few other examples. So now let's say that instead of adding 1 gallon and then subtracting 1 gallon, let's say that our positive flux is actually 2 gallons. And our negative flux remains negative 1 gallon. So what I would do here in this case is I would take my positive flux and I would go ahead and take that, my plus 2 gallons, And I would still, exactly as I did before, I would add my negative flux, my 1 gallon, which we see down here. And my difference here that I end up with is plus 1 gallon, because plus 2 plus negative 1 equals 1 gallon. And once again, my 1 gallon is my net flux. What that means is not that my pool has a gallon of water. What it means is it has 1 more gallon than when we started. We added 2 gallons. We only lost 1 gallon. Let's take the opposite example, and then after this, we'll start getting into some more complicated stuff. Okay, so if we take the opposite example, and suppose that we are only adding 1 gallon of water over here, maybe per minute or per second, and our spigot is actually open at full tilt, and we're actually losing 2 gallons. So what that means, if we go ahead and if we take our positive, we take our plus 1 gallon, and we add our negative, so plus negative 2 gallons, what that means is that we're in the red. We're going to have negative 1 gallon. And so this is the opposite of the previous situation. We're dumping out more water than we're putting in. What that means is that our net flux is 1 gallon. Now, if we were to be technical, we would be adding a time unit in here. We would be saying, you know, we're adding 1 gallon per second, and we're subtracting 2 gallons per second, which means that our net flux is negative 1 gallon per second. We don't have to get too complicated about that. I mean, we're not talking about dimensional analysis or anything really complicated like that. But the important thing is to recognize this is my positive change. This down here is my negative change. The way to figure out the change between the two is simply add them. Always add. Never try to subtract. Otherwise, you might get the order wrong and you'll get confused. So just add the fluxes, and you're going to find the net flux. So before I close off, let's look at just one kind of concrete example of forest, and then we'll move on from there. All right, so let's sort of take a real-world example. Let's take a forest. Now, forest has got the hose pouring in, and it's also got the spigot. And you might be wondering, well, how in the heck are those part of a forest? Well, not literally, but our hose is the atmosphere, because our trees are doing photosynthesis. And so what that really means is that our atmosphere is pumping carbon dioxide into the forest, or I guess I should say the forest is pumping in carbon dioxide. But also don't forget that the forest is also doing respiration. It's doing cellular respiration. So the photosynthesis is kind of like your hose in a pool. And over here, the cellular respiration is kind of like the spigot. So we have our input and we have our output. We have our positive flux, our hose, over here. And then we have our negative flux, our spigot, over there. So if we were to take a real-world example, let's say that photosynthesis over the course of a year or whatever adds 2,000, let's say, pounds per year to our forest. It's actually pulling 2,000 pounds of carbon out of the air. But at the same time, the forest is actually emitting, let's say, I'll take a different number than what we did in class. Let's say that the forest is actually emitting 1,300 pounds per year. So these are fluxes, right? This is my positive flux. This over here is my negative flux. So all we have to do is simply add them up. And what that would do is it would tell us how is the mass of our forest changing. Nobody can go out there and actually weigh a forest. But what we can do is calculate how much carbon is coming in and out. And we could, if we wanted, we could estimate how much the mass of that forest is changing every year. So all I have to do is take my plus 2,000, because that's my positive flux, and then I'm going to add to that my negative 1,300. What I end up with is actually 700 plus. So what this means, 700 pounds per year, is how much my forest is increasing. This would be my net flux, and it is positive. So this is, again, just kind of an introduction, just to give you an idea about what are we talking about when we say flux. So what we're going to do in the next video is we're going to learn how do we graph this over the course of time. How are we supposed to graph this sort of complicated idea.